Hello guys, so today I want to explain a very simple concept in which we are going to do it or put it in our next smart fan project. We want to remove this analog display for speed and put a 7-segment display. But the problem with a 7-segment display is that it's very hard for it to count backwards. So because we want to check the speed and update the speed every single time, we're going to need a circuit which is going to trigger the driver to count once more and again like that to update it. And to do that, we need a separate circuit in which we are going to make. So this is the circuit, and I want to explain what is happening here. So basically we have an NE555 in two modes, A-stable and monostable. I know most of you know about how to connect NE555 in various mode. We are going to measure in A-stable mostly because that's what we want to configure. So an NE555 in A-stable gives a square wave output. So on, off, on, off, on, off, and this delay is determined by the amount of capacitor that you used right here. So we want to modify this output into something like this. So the difference between this one and this one is because is that this bottom one, the on time is shorter than the off time. So the off time is long, then the on time is short. So short on time, long off time, short off time, long off time. And this is what we want, because we want this period is when the 7-segment display is going to be showing you the speed. Then this trigger is going to trigger it and reset it for it to count once again, for it to give you the updated speed of the fan. And that's what we need. So to make that is very easy. We're going to need two NE555s and one NOT gate IC. Not gate IC. As you can see, the LED follows this bottom oscillations, goes on for a short period of time as compared to the off long, then the on time is short than the off time. So as you have said, we need two NE555s and one NOT gate IC. So basically the circuit looks like this. We have the first NE555 which is in A-stable mode, and the other one is in monostable mode. Then so this is the main circuit. This is the main IC which drives the other ones. So once it goes on, once you turn on the circuit, once it goes on, the monostable stays on for a specified period of time. And because the output is connected to these two NOT gates, they are going to give a zero output, because an inverter, that's the function of an inverter, it inverts the input. So if the input is 1, the output is going to be 0. So at that point, nothing really happens. Once the monostable goes off, that off is going to be inverted into the 1. So this one is going to enter the first oscillator, which is pin number 8, which means that it's going to power this IC, which is going to give an oscillation signal. That signal is going to come and enter this BC547. To trigger the monostable, both of these transistors have to be on, and because it was off, also this transistor will be on. And because this one is triggered by the A-stable, it means that you trigger the monostable mode and it's going to turn on. Once it turns on, it's going to turn off these two outputs, and the cycle continues. So that's basically how the circuit operates, and that's what you're seeing in this point here. So stays on, then off for a long period of time, then on again like that. And this can also be modified by these capacitors. If I change them, then it's going to behave differently, as you're seeing in the circuit. So that's basically what I wanted to show you today. It's a very easy concept. If you want to learn about how to connect NE555 in various modes, I'm going to put a link because I did a playlist in which you can connect how you can connect NE555 in various modes. I'll put in the description for you to go and check how to do that, for you to understand what I've done here. So that's basically what I wanted to show you today. So thank you guys for your time, and hope to see you next time. Goodbye.